guys, in this video we are going to discuss about what is stabilization and how it is measured for a circuit, and defining the stability factors S, S dash and S double dash in brief, and also deriving the stability factors S, S dash and S double dash for a transistor in common emitter configuration. So firstly, getting into the question that what is stabilization. The operating point of a transistor acting as an amplifier shifts mainly with changes in ICO, beta and VBE. The process of making the operating point independent of ICO, beta and VBE is known as stabilization. Simply said, we know that the operating point Q point or the quiescent point of a transistor acting as an amplifier changes mainly due to changes in ICO, beta and VBE. You will get to know this if you have watched my previous video on the stability factor and the factors that cause the stability of biasing circuit. So, to measure the stability of a biasing circuit against the variations in ICO, beta and VBE, the three parameters are defined. They are the S, S dash and S double dash. These parameters are known as stability factors. So, the stability factor is the rate of change of collector current IC. The rate of change of collector current I is known as delta IC. With respect to collector base leakage current ICO, at constant VBE, at constant values of IB and beta, is called stability factor S. Now you understood the definition and formula of the stability factor S, and going to S dash, the rate of change of IC, rate of change is delta IC with respect to VBE at constant values of ICO and beta is known as stability factor S dash. Now talking about the stability factor S double dash, the rate of change of collector current IC with respect to beta, delta I beta, at constant values of ICO and VBA is called stability factor S double dash. So the values of S, S dash and S double dash indicate the stability of a circuit. If the values of S, S dash and S double dash are large, the circuit is highly unstable, else the circuit is highly stable. So now talking about the derivation of stability factor S, we know that the collector current IC of a common emitter configuration in terms of beta is given as beta IB plus 1 plus beta into ICO. You have already been familiar with this equation for so many times in the previous classes. So where IB is the base current, beta is the current gain, and ICO is the collector leakage current. So let this be equation number 1, and differentiating equation 1 with respect to IC, we get DIC by DIC is equal to D by DIC of beta into IB plus 1 plus beta into ICO. We know that DIC by DIC is value is equal to 1. So 1 is equal to beta into, since beta is constant, we'll have this out, and D by DIC of IB, the left term IB, plus again 1 plus beta constant, so it's out, and D by DC of DIC of ICO, the collector leakage current. This is gonna be equal to 1 is equal to DIB, beta into DIB by DIC plus 1 plus beta into DICO by DIC, the same term written again. this is equal to 1 is equal to beta into dib by dic plus 1 plus beta into this term can be written as 1, this term can be written as 1 by dic by dico. When turned, it's gonna be dico by dic, the same term. One is equal to beta into dib by dic plus 1 plus beta into, we know that dic by dico is the stability factor S. So this value is gonna be equal to 1 by S. So we can write this as 1 is equal to 1 plus beta by S, 1 plus beta by S plus beta into dib by dic. 1 plus beta by S plus beta into dib by dic, this term and this term written here. One plus beta by S is equal to 1 minus beta into dib by dic. This term gone to the other side, plus this term becomes minus beta into dib by dic. From this step we can write 1 plus beta is equal to S into this whole thing. 1 plus beta is equal to S into 1 minus beta into dib by dic. From this step, S can be written as 1 plus beta by this term going to the other side, 1 minus beta into dib by dic. So this is the stability factor for CE configuration. So now the derivation of stability factor S dash. We know that the stability factor S dash is defined by DIC by dVB. Using the relation IC is equal to beta IB plus 1 plus beta into ICO, S dash can be written as S dash is equal to DIC by dVB is equal to d by dBVB of, in the place of IC here we'll have this whole term beta into IB plus 1 plus beta into ICO, where ICO and beta are constants. So S dash is equal to beta into DIB by dVB. We have derived the expression for stability factor S dash, and now we are going to derive the stability factor S double dash. We know that the stability factor S double dash is defined by DIC by d beta. Again, in the place of IC we'll have d by d beta of beta IB plus 1 plus beta into, this is 1, into ICO. Here, according to the definition, ICO is constant. So S double dash is equal to IB plus ICO plus beta into DIB by di beta, d beta. So we have successfully derived the expressions for S dash and S double dash. Thanks for watching.